spring 1906, South Bend, Indiana. The engineering assessment from European lathe manufacturers would never fully capture what they witnessed in that cramped $65 a month shop. Two Irish immigrant brothers, building precision metalworking equipment using methods that defied everything European industrial tradition said was necessary for manufacturing excellence. Through the grinding of steel and hiss of cooling metal, identical twin brothers, John and Miles O'Brien, worked with timing and precision that seemed impossible to European observers. No massive foundries, no generational expertise, no million-dollar facilities, yet they achieved tolerances of 1/10,000th of an inch that European craftsmen struggled to match. In European factories, precision lathe manufacturing required decades of inherited knowledge. Each machine was essentially hand-assembled using time-tested methods, specialized foundries, and premium materials. Most carried price tags only established manufacturers could afford. The Americans were operating with engineering philosophy the Europeans had dismissed as impossible. Cast iron construction, American precision standards, built-to-last philosophy, quality levels that reduced dependence on expensive European imports. 8,000 miles from European workshops, the most decisive precision manufacturing revolution in industrial history was revealing itself, not in superior tradition, not in premium lineage, but in systematic innovation that connected American determination with engineering excellence European manufacturers never imagined possible. The morning of March 15, 1906, found Miles O'Brien standing in the doorway of what would either become America's answer to European precision manufacturing or the most expensive lesson in industrial humility that South Bend, Indiana had ever witnessed. The one-room shop at $65 per month represented everything the identical Irish twins could afford after pooling their savings from years of working under other men's supervision, learning other men's methods, and watching other men profit from American dependence on European machinery. Miles ran his calloused fingers along the rough brick walls, calculating square footage against the machinery layouts he had sketched in his notebook during sleepless nights. 1,200 square feet. Enough space for two precision lathes if they eliminated every convenience, every comfort, every backup plan except the tools themselves. His brother John stood beside the single window, studying the morning light as it revealed the dust motes dancing in air that would soon fill with metal shavings and the acrid smell of cutting oil. "The Zimmerman letter arrived yesterday," John said, pulling the cream-colored envelope from his coat pocket. Heinrich Zimmerman, representing the established German lathe manufacturers, had responded to their inquiry about purchasing European machinery for their startup operation with the patronizing patience of someone explaining basic arithmetic to children. He suggests we consider becoming regional distributors for their equipment rather than attempting to manufacture our own. Miles took the letter, scanning the carefully worded dismissal that began with praise for American industrial ambition and concluded with gentle warnings about the specialized knowledge required for precision metalworking. Zimmerman emphasized that successful lathe manufacturing demanded generational expertise, massive capital investment, and access to European foundries capable of producing cast iron beds with the necessary molecular structure for vibration dampening. American foundries, the letter explained with diplomatic precision, had not yet developed the centuries-old techniques required for this level of metallurgical sophistication. He mentions that Colchester Manufacturing spent 18 months and $40,000 attempting to build precision lathes in their Hartford facility. John continued, watching his brother's expression. Complete failure. The spindle bearings wore out within 6 months. The ways lost accuracy after minimal use, and the cast iron beds cracked under normal operating stress. Miles folded the letter carefully, his three-fingered left hand, a permanent reminder of his apprenticeship under Thomas Edison at the phonograph company, gripping the paper with practiced efficiency. The missing digits, lost to a gear-cutting accident during his second month in Edison's laboratory, had taught him that precision manufacturing demanded absolute respect for both human limitations and mechanical possibilities. Edison had kept him on the payroll during his recovery, assigning him to study European manufacturing techniques and American material science with equal intensity. Edison told me something the day I returned to work, Miles said, walking to the center of the empty shop where their first lathe bed would eventually rest on carefully leveled foundation blocks. He said American manufacturing would never achieve independence by copying European methods with inferior American materials. We had to discover what American materials could do that European materials could not. The brothers had spent 2 years at Stanley Works in New Britain, Connecticut, learning precision measurement and quality control from foremen trained in European methods. They had enrolled in engineering courses at Purdue University, studying metallurgy and mechanical principles that European craftsmen learned through decades of apprenticeship. Their formal education combined with practical experience created a unique perspective. They understood both the theoretical foundations of precision manufacturing and the economic realities of American industrial competition. John pulled out his notebook, filled with calculations that represented months of market research and financial planning. McCarthy's bicycle. Manufacturing placed a conditional order for 2 lathes, delivery by December 1st. Williams Brothers Machine Shop wants 3 units if we can match German accuracy specifications. Henderson's agricultural equipment needs 4 lathes capable of maintaining tolerances within 0.02 of an inch for their gear cutting operations. Miles nodded, studying the numbers that represented more than potential sales. They represented American manufacturers tired of waiting 6 months for European deliveries, frustrated by premium pricing for standard specifications, and increasingly convinced that domestic alternatives could serve their needs if someone could solve the technical challenges. The Spanish-American War had demonstrated American manufacturing capability under pressure, but peacetime competition required sustained excellence rather than emergency innovation. The foundry problem remains, Miles said, addressing the central technical challenge that had defeated previous American attempts at precision lathe manufacturing. European cast iron beds achieve their vibration-damping properties through specialized sand compositions and cooling techniques that American foundries have not mastered. Without proper foundation stability, no amount of precision machining can compensate for structural inadequacy. John walked to the far corner of the shop, where they planned to install their first casting facility. Unless we develop our own foundry techniques specifically for American materials and conditions, Edison proved that American innovation succeeds by solving problems differently rather than copying established solutions perfectly. The financial reality remained stark. Their combined savings of $800 would cover 3 months of rent, basic tooling, and raw materials for perhaps 2 prototype lathes. European competitors operated from facilities worth millions of dollars, employed craftsmen trained from childhood in precision techniques, and maintained customer relationships built over decades of reliable service. The O'Brien brothers possessed technical knowledge, practical experience, and determination to prove that American engineering could achieve European precision through innovation rather than imitation. Miles examined the concrete floor where their first lathe would take shape, visualizing the cast iron bed that would either validate their confidence in American manufacturing potential or confirm European skepticism about New World precision capabilities. The success or failure of their enterprise would ultimately depend not on matching European methods, but on discovering what American materials, American techniques, and American determination could accomplish when combined with rigorous engineering standards and absolute commitment to excellence. The challenge was impossible by every conventional measure. The opportunity was precisely what American manufacturing needed to achieve genuine independence from European technical dominance. By October of 1906, the O'Brien brothers had transformed their skepticism about European foundry techniques into systematic experimentation that would either revolutionize American cast iron production or consume their remaining capital in spectacular failure. Miles stood over the custom sand mixture he had developed through 43 separate casting attempts, each failure teaching him something essential about how American iron ore behaved differently under controlled cooling conditions than the German materials European foundries had perfected over centuries. The breakthrough came from an unexpected source. While European foundries relied on specialized sand imported from specific German regions, Miles discovered that Indiana Lake sand, when combined with precise ratios of clay and coal dust, produced cast iron beds with superior vibration damping properties. The key lay not in copying European sand compositions, but in understanding how American materials responded to controlled cooling rates that European foundries had never needed to develop. John recorded the specifications as Miles explained each variable that contributed to their casting success. The sand mixture required exactly 12% clay content, 3% coal dust, and 85% lake sand sifted through 60 mesh screens to eliminate particles larger than 250 micrometers. The molten iron had to reach exactly 2,700 degrees Fahrenheit before pouring, then cool at a controlled rate of 50 degrees per hour for the first 12 hours to prevent internal stress formation that would compromise long-term dimensional stability. The German approach assumes consistency in raw materials that American suppliers cannot guarantee, Miles said, examining a cross-section of their latest casting under magnification that revealed the crystalline structure responsible for vibration absorption. Our method compensates for material variations through process control rather than material selection. Their first complete lathe bed weighed 2,400 pounds, nearly 3 times heavier than comparable European models, but achieved vibration dampening that exceeded German specifications by measurable margins. Miles had discovered that American iron ore, when properly processed, produced denser castings with superior harmonic characteristics that actually improved cutting performance rather than merely matching European standards. The precision machining presented different challenges that demanded innovations in American tooling techniques. European lathes achieved their legendary accuracy through hand scraping performed by craftsmen trained from childhood, in techniques passed down through generations of master machinists. The O'Brien brothers had neither generational expertise nor the luxury of decades-long apprenticeships, forcing them to develop systematic methods that could achieve equivalent precision through mechanical consistency rather than inherited skill. Miles designed custom scrapers that removed metal in controlled increments of 25 thousandths of an inch per stroke, allowing him to achieve surface finishes accurate to within 1/10,000th of an inch across the entire length of 48-inch latheways. The process required 18 hours of continuous scraping per lathe bed, with measurements taken every 6 inches using precision straight edges, accurate to 50 millionths of an inch. John monitored the financial implications as Miles refined their manufacturing processes. Each lathe required 46 hours of direct labor, 62 pounds of cast iron, 28 separate machining operations, and materials costing $137. European competitors charged $850 for comparable equipment, leaving sufficient margin for the O'Brien brothers to price their lathes at $600 while maintaining profitability that could sustain business growth. The spindle bearings represented their most critical innovation challenge. European manufacturers used bronze bearings machined to tolerances of 5/10,000ths of an inch, adequate for their lighter cast iron beds, but insufficient for the precision demands of American manufacturing applications. Miles developed white metal bearings using tin, antimony, and copper alloys that could maintain tolerances of 2,500 thousandths of an inch, while supporting the increased loads generated by their heavier, more rigid lathe construction. The bearing manufacturing process required melting the white metal alloy at exactly 400 degrees Fahrenheit, pouring it into precisely machined bearing shells, then boring the finished bearings to final dimensions using tools ground specifically for each bearing diameter. Miles discovered that American white metal alloys, when properly heat-treated, provided superior wear characteristics compared to European bronze bearings while maintaining dimensional stability under varying temperature conditions. By December of 1906, their first complete lathe demonstrated capabilities that challenged fundamental assumptions about American manufacturing potential. Test cuts in hardened steel maintained dimensional accuracy within 1,000th of an inch across 12-foot lengths, surface finishes that matched German standards, and spindle precision that exceeded European specifications for concentricity and parallelism. William McCarthy arrived on December 15th to inspect the lathe he had ordered conditionally 8 months earlier. His bicycle manufacturing operation required precision gear cutting that demanded lathe performance traditionally available only from German imports at premium pricing with extended delivery schedules. McCarthy brought test materials identical to those used in his production processes, including hardened steel blanks that would reveal any deficiencies in cutting precision or surface finish quality. Miles demonstrated the lathe's capabilities by cutting a series of increasingly demanding test pieces, beginning with simple cylindrical turning and progressing to complex tapered shafts with multiple diameter changes that required maintaining tolerances within half a thousandth of an inch. The lathe performed each operation with consistency that matched McCarthy's most demanding production requirements while operating more quietly than the German equipment in his existing facility. The vibration levels are significantly lower than our imported machines, McCarthy observed, placing his hand on the lathe bed during heavy cutting operations. The surface finish quality exceeds our German lathe performance, and the dimensional consistency appears superior to equipment costing 40% more. John documented McCarthy's observations while calculating production schedules that could fulfill pending orders from 3 additional customers who had expressed interest contingent on successful demonstration of American precision manufacturing capabilities. Their systematic approach to solving European technical challenges through American innovation had produced measurable results that validated their confidence in domestic manufacturing potential. The first South Bend lathe shipped to McCarthy's facility on December the 20th, 1906, representing more than successful completion of their initial sale. It demonstrated that American engineering, American materials, and American manufacturing techniques could achieve precision previously available only through European expertise, establishing the foundation for industrial independence that would transform American manufacturing from importer to global leader in precision machinery production. William McCarthy's bicycle manufacturing facility became the proving ground that would either validate American precision lathe manufacturing or expose the limitations that European competitors confidently predicted. By February of 1907, McCarthy had operated his South Bend lathe for 6 weeks under production conditions that demanded consistent accuracy, reliable performance, and dimensional stability that matched his most demanding gear cutting requirements. The results exceeded every expectation McCarthy had developed during 20 years of manufacturing experience with imported German equipment. His production supervisor reported that the American lathe maintained cutting tolerances within half a thousandth of an inch across 8-hour shifts, surface finishes that required no secondary operations, and spindle accuracy that remained constant despite heavy cutting loads that would have compromised lesser equipment. Most significantly, the lathe operated with vibration levels 40% lower than his German machines, producing components with dimensional consistency that improved his final product quality while reducing material waste. McCarthy scheduled a demonstration for 5 neighboring manufacturers who had expressed skepticism about American precision capabilities. On March 8, 1907, representatives from Williams Brothers Machine Shop, Henderson Agricultural Equipment, Morrison Gear Company, and 2 Chicago area toolmaking firms gathered in McCarthy's facility to witness cutting demonstrations that would determine whether American lathe manufacturing represented genuine innovation or temporary wartime expedient. Miles O'Brien arrived with cutting tools he had designed specifically for their lathe geometry, including carbide-tip tools that maintained sharpness longer than traditional high-carbon steel cutters used with European equipment. The demonstration began with standard turning operations that any competent lathe should handle easily, then progressed to increasingly demanding cuts that would reveal any deficiencies in spindle precision, bed stability, or overall mechanical integrity. The most challenging test involved cutting interrupted surfaces on hardened steel blanks with varying material properties that would expose any weakness in the lathe's ability to maintain consistent cutting forces despite changing conditions. European lathes typically struggled with these applications, requiring reduced cutting speeds that compromised productivity. The South Bend lathe completed the entire series without adjustment, maintaining surface finish quality and dimensional accuracy that impressed experienced machinists accustomed to German precision standards. Henderson's purchasing manager placed an order for 3 lathes before leaving McCarthy's facility that afternoon. Williams Brothers ordered 2 units with delivery requested within 4 months. Morrison Gear Company, after witnessing cutting demonstrations that exceeded their German lathe capabilities, committed to 4 units with specifications for their most demanding gear cutting applications. By the end of March 1907, the O'Brien brothers had accumulated orders for 14 lathes with total value exceeding $8,000. The production challenge demanded systematic scaling that maintained their precision standards while increasing manufacturing efficiency. John negotiated a lease on the abandoned Singer sewing machine plant facility, providing 12,000 square feet of manufacturing space with overhead cranes, power distribution systems, and floor space adequate for simultaneous production of multiple lathes. The monthly rent of $240 represented significant financial commitment, but offered the infrastructure necessary for meeting their expanding order backlog. Miles developed production methods that preserved hand-scraped precision while reducing labor requirements through systematic tooling and measurement techniques. He designed master templates for critical dimensions, precision fixtures that ensured consistent machining accuracy, and specialized measuring instruments that allowed less experienced workers to achieve results previously requiring decades of training. The systematic approach enabled production scaling without compromising the quality standards that distinguished their lathes from European competition. By October of 1907, South Bend Lathe Works employed 18 workers producing 4 completed lathes per month. Each unit required examination and approval by Miles personally before shipment, ensuring that every lathe met specifications for spindle accuracy within 25 thousandths of an inch, bed straightness within 1/10,000th of an inch per foot, and surface finishes that matched German standards. The quality control process identified and corrected deficiencies before they reached customers, building reputation for reliability that generated referral sales exceeding their advertising efforts. Customer feedback provided validation that transcended technical specifications. Morrison Gear Company reported that their South Bend lathes produced gears with tooth spacing accuracy superior to their German equipment while operating at higher cutting speeds that increased productivity 23%. Henderson Agricultural Equipment discovered that American lathes maintained dimensional stability in their unheated workshop conditions, where German machines required seasonal adjustment to compensate for thermal expansion effects. The breakthrough moment arrived in January 1908, when Thomas Edison visited their facility to evaluate lathes for his West Orange laboratory. Edison's endorsement carried weight throughout American manufacturing, and his technical requirements exceeded those of typical commercial customers. Edison specified spindle accuracy within 100,000th of an inch, cutting capability and exotic alloys used for phonograph components, and reliability standards that could support continuous operation in laboratory research applications. Miles personally supervised construction of Edison's lathe, implementing precision standards that pushed their manufacturing capabilities beyond previous limits. The spindle bearings required white metal alloys mixed to tolerances measured in parts per thousand, bed scraping accurate to within 50 millionths of an inch, and assembly techniques that eliminated every source of mechanical play or dimensional variation. The completed lathe demonstrated performance that impressed Edison's laboratory machinists, leading to additional orders for his manufacturing facilities in New Jersey and Ohio. By December 1908, South Bend Lathe Works had delivered 63 lathes to customers across 15 states, establishing distribution relationships with machinery dealers in Chicago, Cleveland, Detroit, and Pittsburgh. Production had increased to 12 units per month with quality consistency that generated repeat orders from satisfied customers who discovered that American precision manufacturing offered advantages beyond competitive pricing. John's financial records documented transformation from experimental startup to established manufacturing operation. Monthly revenue exceeded expenses by margins sufficient for facility expansion, equipment acquisition, and workforce development that could support continued growth. More importantly, customer satisfaction surveys indicated that South Bend lathes were perceived as superior to European alternatives in durability, precision maintenance, and suitability for American manufacturing conditions. The success attracted attention from European competitors who had initially dismissed American precision manufacturing as temporary wartime phenomenon. German trade publications began analyzing American lathe specifications, acknowledging technical achievements that challenged assumptions about New World manufacturing capabilities. Heinrich Zimmermann's company initiated correspondence requesting technical collaboration that represented complete reversal from their original dismissive attitude toward American precision manufacturing potential. The influenza arrived in South Bend during the third week of September 1918, carried by returning soldiers from Camp Custer who brought more than military experience back to their civilian jobs. Within 10 days, 7 of the O'Brien brothers' 43 employees had fallen ill with symptoms that began as mild fever and progressed to the respiratory complications that would claim 675,000 American lives before the pandemic subsided. Miles discovered the severity of their situation on October 2nd when he arrived at the Singer plant to find only 19 workers at their stations, the remainder either bedridden with influenza or tending to sick family members. The casting operation required minimum crews of 8 workers to handle molten iron safely, but only 5 foundry workers remained healthy enough for duty. John faced the mathematical impossibility of maintaining production schedules that depended on full workforce coordination when nearly half their employees were unavailable for indefinite periods. The economic impact compounded the human tragedy in ways that threatened everything they had built over 12 years of systematic growth. Henderson Agricultural Equipment canceled their order for 6 lathes scheduled for November delivery, citing cash flow problems caused by their own workforce disruptions and canceled customer orders. Morrison Gear Company requested postponement of 4 units originally scheduled for December, explaining that their manufacturing operations had ceased entirely due to illness among key personnel. By November 1st, South Bend Lathe Works had received cancellations for 23 lathes, representing $14,000 in lost revenue, while their inventory of completed units accumulated in the shipping area with no immediate buyers. John's financial projections revealed that 6 months of reduced sales would exhaust their operating capital, forcing either massive workforce reduction or complete shutdown of manufacturing operations. The post-war economic recession intensified pressures that influenza had initiated. American manufacturers who had expanded capacity during wartime military production discovered that peacetime demand could not absorb their increased output, leading to widespread factory closures and unemployment that eliminated the industrial customers South Bend Lathe Works depended upon for sustained sales. Machinery dealers reported inventory accumulations that prevented new purchases, while established customers postponed equipment replacement indefinitely. European competitors seized the opportunity to flood American markets with inventory they had accumulated during wartime restrictions on Atlantic shipping. German lathe manufacturers offered equipment at prices 20% below pre-war levels, subsidized by government programs designed to recapture American market share that German companies had lost to domestic producers during the conflict. Heinrich Zimmermann's company established distribution warehouses in New York and Chicago, providing immediate delivery that contrasted sharply with South Bend's reduced production capabilities. The technical reputation that had sustained their growth through 10 years of competition faced systematic challenge from competitors who questioned whether American precision manufacturing had been temporary wartime phenomenon rather than genuine innovation. Trade publications published articles suggesting that American lathe quality had benefited from reduced competition rather than superior engineering, implying that peacetime conditions would reveal limitations that wartime urgency had concealed. Miles confronted the crisis through engineering analysis that treated business problems as technical challenges requiring systematic solutions. He calculated that their manufacturing costs exceeded sustainable levels due to inefficiencies that prosperity had allowed them to ignore. Each lathe required 68 hours of direct labor, when European competitors achieved comparable results in 45 hours through manufacturing techniques that American producers had dismissed as inferior. The solution demanded fundamental reconsideration of their production methods without compromising the precision standards that distinguish South Bend lathes from European alternatives. Miles developed new casting techniques that reduced foundry labor by 30% while maintaining dimensional accuracy within their established tolerances. He redesigned machining sequences that eliminated redundant operations, reduced setup time between different lathe sizes, and improved workflow efficiency throughout their manufacturing process. John negotiated with creditors who demanded payment, schedules that seemed impossible given their reduced cash flow, but who agreed to modified terms that provided breathing room for implementing Miles's efficiency improvements. The First National Bank of South Bend extended their operating credit line contingent on monthly progress reports, documenting cost reduction and production improvement that would restore profitability within 6 months. The workforce reduction became inevitable despite John's efforts to avoid layoffs that would eliminate experienced employees whose skills represented years of training investment. 23 workers received termination notices in December 1918, reducing their payroll costs by 40% while concentrating remaining work among their most capable employees. Miles personally met with each terminated worker, explaining the economic necessity while promising rehiring priority when business conditions improved. The darkest moment arrived in February 1919 when their largest customer, Edison's West Orange Laboratory, canceled an order for 8 lathes that represented their most significant revenue opportunity for the first half of the year. Edison's purchasing manager explained that budget restrictions forced postponement of all equipment acquisitions until economic conditions stabilized, eliminating sales that John had counted upon for meeting their loan obligations. European trade publications celebrated American manufacturing difficulties with articles proclaiming the end of New World competition in precision machinery markets. German manufacturers announced expansion plans for American distribution networks, confident that domestic producers would prove unable to compete against European efficiency and established reputation when wartime protection disappeared. Miles spent sleepless nights in the empty factory, examining lathes that represented 12 years of innovation and development, but which no customers could afford to purchase. The machines that had proven American manufacturing capability sat silent in shipping areas while their creators faced the possibility that European skeptics had been correct about American precision manufacturing representing temporary aberration rather than sustainable competitive advantage. John reviewed financial statements that documented their transformation from profitable growth to potential bankruptcy within 6 months, wondering whether their success had been built on wartime conditions that peacetime economics would prove unsustainable. The brothers who had challenged European industrial dominance now faced the possibility that their challenge had been premature, their confidence misplaced, and their American answer to European precision manufacturing nothing more than expensive demonstration of New World ambition exceeding New World capability. The influenza pandemic and post-war recession had revealed vulnerabilities that prosperity had concealed, testing whether American manufacturing innovation possessed the resilience necessary for long-term competition against European industrial traditions that had survived centuries of economic disruption. The solution emerged from crisis itself during the first week of March 1919, when Miles realized that surviving customers needed equipment that performed better rather than equipment that cost less. European competitors had flooded American markets with reduced prices, but their machines still carried the fundamental limitations that American innovation had originally addressed: lighter construction, shorter service life, and precision standards adequate for European applications but insufficient for American manufacturing demands. Miles initiated the most comprehensive redesign in South Bend Lathe Works history, targeting manufacturing efficiency without compromising the engineering excellence that had established their reputation. The key breakthrough involved reconfiguring their casting process to produce lathe beds in half the time while improving dimensional accuracy beyond their previous standards. He developed new sand mixture ratios that eliminated secondary machining operations, reducing labor requirements by 42% while achieving surface finishes that required no additional processing. The redesigned manufacturing sequence consolidated 17 separate machining operations into 12 integrated processes that maintained precision standards within 2500 thousandths of an inch, while reducing production time from 68 hours to 41 hours per lathe. Miles achieved this efficiency through systematic analysis of each operation, eliminating redundancies that had accumulated during their rapid growth period and optimizing workflow patterns that minimized handling time between manufacturing stages. John negotiated with suppliers who had extended credit during their crisis period, securing materials at reduced costs in exchange for guaranteed purchase volumes that provided suppliers with predictable revenue during uncertain economic conditions. The supply agreements reduced their raw material costs by 28% while ensuring availability of specialized alloys and precision components necessary for maintaining quality standards that distinguished South Bend lathes from European competition. The efficiency improvements enabled price reductions that made South Bend lathes competitive with European imports while maintaining profit margins sufficient for business sustainability. John calculated that their new manufacturing costs allowed pricing at $520 per lathe compared to $600 previously, matching German competition while providing superior performance characteristics that justified customer preference for American equipment. The market response exceeded their most optimistic projections. Henderson Agricultural Equipment, which had canceled orders during the crisis, placed a new order for 8 lathes after comparing South Bend's improved pricing with European alternatives and discovering that American equipment offered better value despite comparable initial cost. Morrison Gear Company ordered 6 units, explaining that their analysis of total cost of ownership favored South Bend lathes due to longer service life and lower maintenance requirements. By July 1919, production had returned to 12 lathes per month, with order backlog extending 4 months into the future. The workforce increased to 32 employees as business recovery justified rehiring experienced workers who had maintained their skills during temporary layoffs. Miles personally welcomed back each returning employee, acknowledging their contribution to company survival and explaining how efficiency improvements had created more secure employment opportunities. The technical validation came through independent testing that confirmed South Bend's superiority over European alternatives in measurable performance categories. The American Society of Mechanical Engineers conducted comparative analysis of American and German lathes, documenting that South Bend equipment maintained dimensional accuracy longer, operated with lower vibration levels, and required less frequent adjustment than imported machines. The SME report provided objective evidence supporting American manufacturing claims that had previously relied on customer testimonials and anecdotal evidence. Thomas Edison's return as a customer in September 1919 represented symbolic vindication of their engineering approach and business resilience. Edison's laboratory ordered 12 lathes for research applications that demanded precision exceeding normal commercial requirements, specifying performance standards that only South Bend had consistently achieved. Edison personally visited their facility to observe manufacturing processes that had enabled survival through economic crisis while maintaining quality standards that impressed his laboratory technicians. The Navy Department conducted evaluation testing that positioned South Bend lathes against European competition for government contracts worth over $200,000. Naval engineers specified requirements for continuous operation under demanding conditions, precision maintenance in marine environments, and reliability standards that could support critical manufacturing applications. South Bend lathes outperformed German, Swiss, and British alternatives in every tested category, leading to contracts that established government confidence in American precision manufacturing capabilities. By December 1919, South Bend Lathe Works had achieved monthly production of 18 units with quality consistency that generated referral sales throughout American manufacturing industries. John's financial records documented complete recovery from crisis conditions, with monthly profits exceeding pre-war levels despite competitive pricing that had enabled market expansion. More significantly, customer satisfaction surveys indicated preference for American equipment based on performance characteristics rather than patriotic sentiment or price considerations. The international recognition arrived when Heinrich Zimmermann's company initiated technical collaboration discussions that represented complete reversal from their original dismissive attitude toward American manufacturing potential. German engineers requested detailed specifications for South Bend casting techniques, acknowledging innovations that had achieved results. European foundries had not matched despite centuries of experience with precision metalworking. Henry Ford's Highland Park facility placed orders for 24 lathes in January 1920, specifying South Bend equipment for manufacturing applications that demanded precision and reliability, exceeding European capabilities. Ford's purchasing decision validated American lathe manufacturing at the highest levels of industrial production, demonstrating that domestic equipment had achieved performance standards worthy of the most demanding manufacturing applications in American industry. The statistical proof emerged through Commerce Department analysis, documenting that South Bend Lathe Works had captured 30% of American precision lathe sales by 1920, transforming from startup operation to market leader within 14 years of John and Miles O'Brien's initial investment in their $65 per month shop. The brothers, who had challenged European industrial dominance with nothing but engineering knowledge and immigrant determination, had created manufacturing capability that established American independence in precision machinery production. The legacy extended beyond commercial success to fundamental transformation of American industrial capability. South Bend lathes were producing the tools that would manufacture American automobiles, aircraft, and precision instruments that would define 20th century technological leadership. The engineering excellence that had enabled survival through wartime prosperity and peacetime crisis had established foundation for American manufacturing dominance that would reshape global industrial competition for generations. Miles O'Brien's vision of American precision manufacturing had evolved from impossible challenge to proven reality, demonstrating that New World innovation could surpass Old World tradition through systematic engineering and determination to exceed rather than merely match established standards of excellence.